Hello, Chiz. Thank you for your question. Okay, so let's start by answering this one first. Which of these substances has permanent dipole-dipole interactions between the molecules? Okay, so what we're going to do is we're going to draw each one of them. So starting with CCl4. Now, what you want to do is the question is saying which molecule has which molecules have dipole between the molecules, not between the bonds. So we're not looking for polar bonds, we're looking for a polar molecule. So first of all, CCl4, when you draw it as a 3D shape, you get this tetrahedral. We know that carbon and chlorine bonds are polar. However, is this molecule polar? So to do that, what you're going to do is look for, is there an area where one side is negative and the other side is positive? So if we have a look here, we can see the center is positive, but around it is negative, and there isn't any distinct region. So for example, if I was to draw across here, I'm going for a negative, then for a positive, then back through a negative. So there isn't really two distinct regions. So therefore, it's although it has polar bonds, it's not a polar molecule. Okay, moving on to the next one. Again, if you draw this C2F4, we can see that those parts are negative, the center is positive. However, again, there is no distinct region where one side is negative, one side is positive. Moving on to the next one, this is propanone. The only part where the bond is polar is between carbon and oxygen. So over here, if I draw out, there we go. So we can see one side is positive, the other side is negative. And in this one, there is two distinct regions. So this molecule, is also a polar molecule. And finally, if I do the last one just to make sure, carbon dioxide, yes, it does have polar bonds. However, is it a polar molecule? No. Why? Because you can see that there's negative, positive, and negative again. Okay, so the answer is going to be the third one, propanone. Moving on to the next question. So we want to draw AsCl3. So As is in group 5. It has 5 electrons in its outer shell. Chlorine has 1 electron in its outer shell. So of course, the rule with covalent bonding is you get what you give. Chlorine has 7 electrons, it needs 1 more, so it shares 1. Now we have 3 chlorines, so we're going to put the other 3, just like that. And now if you look at your central atom, this guy, it has 3 bonded pairs and 2 lone pairs. Therefore, it gives it a 3 bonded and 1 lone pair. And therefore, it looks like a trigonal pyramidal with 107.5 degrees. Moving on to the next question. So Cl3+. So this is one molecule of 3 chlorines joined together. However, one of the chlorines has lost an electron. So instead of having 7 electrons like chlorine normally does, it has 6 electrons. So here I've drawn that one. So there's chlorine with 6 electrons. The next 2 chlorines will just be normal chlorines with 7 electrons. So I'm going to put, now again, remember these guys have 7, so they just each need 1 more. So if I put them on here, I can see now that both the blue chlorines have 8 electrons. They're happy. The middle one has 1, 2, 3, 4, 5, 6, 7, 8, also has 8 electrons, and therefore the final shape of this would be 2 bonded pairs, 1 lone pair, and that is bent. So I'm going to answer the other questions in the next video.